will take much less. Please get used to this table. Everything we find, we're going to put it in the table, and after we fill up the table, we will be able to graph the function without looking anywhere. So I'm asked to graph this function and find everything. I cannot start with the first derivative. I cannot start, of course, with the second derivative. I have to analyze the function first. And what is the analysis about the function? First, we know the domain is all real numbers because this is a polynomial function. I will have to find the limits at infinity and negative infinity, and I will have to find the x and y intercepts. I have to have 0 in the table, and you'll tell me what I have to write for the function when x is 0, what is the value of the function. Very good, thank you very much. Can anyone look at this function and determine the limit here? The limit of f of x as x approaches infinity, and the limit of f of x as x approaches negative infinity. When we determine the limits at infinities for this function, which of these three terms is the most powerful term? At infinity, only when we talk about infinities. Which one? I'm assuming you said x to the fourth because for some reason I couldn't hear it. So then plug in negative infinity and tell me what to write. Anyone?
Oh, would it be negative? That would be infinity.
So what do I put here?
Infinity.
And here?
Infinity.
Of course. Now, how do I find the x-intercepts? Quickly, with the graphing calculator. With apps, 9. Yes, it's a polynomial, this is degree 4. Okay. And 1, 0, negative 2, 0, and 3. Okay. So it appears that it has, did I click on something else than polynomial? Root finder, degree, because I'm surprised of this, because x to the fourth minus 2x squared plus 3 is x squared minus 3, and x squared minus 3 plus, yeah, actually, yeah, nope, okay. So it has no real solutions. I see. Right? Graph. I entered everything correctly. 1 and negative 2 for x squared, x to the fourth, negative, yep, yep. and solve. So these are imaginary solutions. Aha, see, there is an I there. I. Because it cannot have two pieces. If it has two pieces, they are imaginary. Okay, so careful on that. Good? Okay, fine. No problem. Then we will continue with the first derivative. 4x to the third minus 4x. Nice. There is never undefined, but it could be equal 0. So 4x cubed minus 4x, correct. So then 4x, x squared minus 1 equals 0. And then I factor x plus 1, x minus 1. So there are three solutions. 0, -1, and 1. X equals 0, x equals 1, x equals -1. I found something. It has to find its place. Good. So I found three critical numbers. They are in the table. The derivative is 0, not undefined. All I need to find now is the sign here. I will plug 4x cubed minus 4x in the calculator. Okay, 4x cubed minus 4x. It's easier to put those values in the product form, but that's okay. So maybe for some of you it's easier to, okay, so a -4, -0.5, 0.5, and 10. So the sign is negative, positive, negative, positive. Negative, positive, negative, positive. I cannot draw any conclusions yet. I have to find this value, and I have to find this value. Since the function is even, both numbers will be the same. So 1 minus 2 and -1. -1 plus 3 is 2. So 1 plus 4, 4 minus 2. Okay, now the moment of truth. This row and this row have to work well together. If they don't, I'll say oops and go back to the drawing board. From infinity to 2, what does the function do?
Decrease.
Yes. Is that correct? Is that supported by the sign of the derivative?
Yes.
Perfect. From 2 to 3, what does the function do? And if that's supported by the sign of the derivative? From 2 to 3, it's increasing, and that is supported by the sign. From 3 to 2, yes. From 2 to infinity, yes. So this row and this row work well together. Finally, the second derivative. Here's my first derivative. So the second derivative will be 12x squared minus 4. Of course, it's never undefined, but it could be 0. So when 12x squared minus 4 equals 0 means x squared equals 4 over 12, which is 1/3. Ugly number, but I have no choice. That's what it is. And I will approximate them because I don't know what to do with that. So first, I will plug them in to find where is my function. This is my function. No, this is not my function. So my function is x to the 4th minus 2x squared, and then plus 3. Okay, so the function, what I want to determine for the function is the values at the square root. This is awful, but that's what it is, 1/3. Okay, that was at 1/3, and I also want, it will be the same because it's even. So negative, The function is here, 2.4. Okay, I found something. So, oh, what I forgot is, so 2.4 in both, but I need one more thing. I need to evaluate, oh, well, we already did that. What was the value? 0.6, got it. So back to the table, negative 0.6 and positive 0.6, 0 and 0, and I need to find this value here, which we just did. Back, it was 2.44. So 2.44, it has to be a number between these two. So 2.44. Finally, I study the sign of the second derivative. So I will plug in this, but it's so much easier. When I plug in 0, I get negative. And when you plug in outside, it will be positive because it's quadratic. Holds water, does not. Holds water. And now finally we will analyze what each point represents. So can anyone tell us what point is negative 1, 2? Negative 1, 2. What type of point is it?
It's a relative minimum.
Yes, perfect. What type of point is negative 0.6, 2.4? IP.
With a relative max.
IP. Inflection point. So when I show the second derivative, this must be an inflection point. When we talk about the first derivative, positive, negative. So what type of point is 0, 3?
Relative max.
Excellent. What type of point is 0.6, 2.44?
Inflection point.
Yes, inflection point. Finally, what type of point is 1, 2?
Relative.
Min. Indeed. And it makes sense. There is a critical number, and the function looks like this. It has to be a relative min. There is a critical number, and the function looks like this. It must be a relative max. There is a critical number here, and the function looks like this. It must be a relative min. We have everything now. I'm ready to graph. Don't get scared. We're going to practice this a lot with many functions. Okay. Nothing else matters. Here's my graph. I start by plotting the points. Always plot the points. Negative 1, 2. Negative 0.6, 2.4. 0, 3. 0.6, 2.4. And 1, 2. It's coming from positive infinity opening up to the relative min. It's increasing, still opening up, increasing to this point, which is the point of inflection. It changes concavity, going to the relative max. Continues to decrease now to the next inflection point. It changes concavity, reaches a minimum, goes to infinity. So this is f of x. X to the fourth minus 2x squared plus 3. It turns out that these 2 points, negative 1, 2, 1, 2, they are not just relative minimum, but also what?
Absolute minimum.
Absolute minimum, indeed. And I have to write it here. and absolute as well.